once again to Simple Easy or Simple Easy Lessons. If you want anything that will be a memory trick, then this is the channel to consult. So in this particular discussion, we'll be considering that of the thermal physics. In the last video, we look at that of the Boyle's law. Today we'll look at the various laws and see how to wrap up the thermal physics and the gases, and then we move on to other physics topics like that of the in the same concept, the thermal physics, where you have to find the heat capacity and then the rest, and we'll see how to do that as well. So you are welcome once again to this channel. Stay tuned as we study on this particular channel. In the last video, we looked at Boyle's law, and we said that for Boyle's law, what you have to remember is that I said boys are VIP, boys are what? Boys are VIP. I hope you remember VIP. And then we said from this one we can deduce that Boyle's law here. Boyle's law here states that for Boyle's law, volume IM is inversely proportional to the pressure. That Boyle's law says that at constant temperature, the volume of a given mass of gas is inversely proportional to the pressure. Now, in today's discussion, if you have not watched this, kindly go to the next video. You get that about that. And so the last video, the previous video, don't forget to subscribe as well. Now, in this particular concept, we'll be looking at the second one, which is the Charles law. I term it vote for Charles. So today we are looking at Charles law. So remember, vote for Charles. Vote for Charles. Anybody by name Charles, we are going to vote for you. Is that okay? So vote for Charles. If you remember vote for Charles, what do you have to remember? I told you that all this one, there are three things we are looking at. There are three things we are basically looking at for all the laws. We are looking at the volume, we look at the pressure, and we look at the temperature. These are the three elements we'll be considering. Now, today we are looking at the Charles law. Charles law here, remember vote for Charles. Vote for Charles. Vote for Charles means that if you remember the word vote, which is a key word we want to look at here, vote. Vote here, vote here. So you want to remember vote, right? Vote. That the volume is directly proportional to the temperature. The volume is directly proportional to the temperature. So here, what is constant? Among these three elements, what is missing here? That is the pressure. It means the pressure is constant. If you're looking at the Charles law, remember the word vote, right? So if they ask you to state the Charles law, you remember this one, that at a given mass of gas, for a given mass of gas, the volume is directly proportional to the temperature at a constant pressure. Or somebody can say that the volume of a fixed mass of gas at a constant pressure is directly proportional to what? The thermodynamic what? Temperature. When we say thermodynamic temperature here, we're looking at the temperature in Kelvin. And so that is what we are looking at. So Charles law, remember, vote for Charles. Alright, so you see that it says here that what? As we can see, vote for Charles, which means that volume is directly proportional to the temperature for the Charles law. So here we are saying that that the volume of a given mass of gas is directly proportional. So the volume of a given or a fixed mass of gas at constant what? What is constant among these three elements? Pressure. At constant pressure is directly proportional to its thermodynamic temperature. Now let me explain this before we move on. Now you see, when we say thermodynamic temperature, it means that the temperature in Kelvin. Now how do you convert from degrees Celsius to Kelvin? When you add 273 to degrees Celsius, you get Kelvin. Don't forget this. Okay, so if I give you 20 degrees Celsius, you want to convert to thermodynamic temperature, you add 273 to it. Okay, and that will give you what? 293 Kelvin. Good. So that's what we want to do. Now, this is what they usually ask you. They can give you two gases and you ask you to relate it. Now, I told you anytime you want to relate, put a constant there, then you cannot relate. So now if you say volume is directly proportional to the temperature, then we can say that V here is equal to a constant. If I'm bringing an equal to sign, a constant T. So we can make it a subject so that you can relate. So we can say K here is equal to V over T. Is that not it? So therefore we can say from this relation, we can say V1 over T1 is equal to V2 over T2. And this gives us two relations. So volume 1 over temperature 1 will give you volume 2 over temperature 2. Or you can say the initial volume and initial temperature for the 1, and the 2 give you the final or the new volume and the new temperature. So that's for the Charles law. Let's see how we can solve some questions with that of the Charles law. Alright, so the second question, the first question on this particular one. A gas which obeys Charles law has a volume of 283 centimeter cube at 10 degrees Celsius. Calculate the volume at 30 degrees Celsius. So with this particular one, we are using the Charles law. So we know that the Charles law here, what we know is that we know V1, remember both V1 over what? V1 over T1 should give you what? V2 over T2, is that not it? Good. So if that is what we know, we want to first of all, we know the relation. Now we are given what? The volume. What is V1? V1 was given as what? 283 centimeter cube. What was the temperature? The T1. T1 here was what? It was 10 degrees Celsius, but we add it what? 273 to it, so that we can get the absolute temperature or the thermodynamic temperature. And this is going to give us 283 Kelvin. Now, what is our V2? We don't know our V2, but what's our T2? T2 is 30 degrees Celsius, which will add 273 to it, and that's going to give us what? 303 Kelvin. Now, we are going to do the Charles law, and we know quickly, I know volt. So volt, if I make this in a subject, we are going to have V equal to KT. If I make K the subject, I'll have V over T. So what am I going to use? V1 T1 equal to V2 T2. So that's the main thing you need there. So V1 T2. So let's make V2 the subject. If I cross multiply, we know we are going to have V2 times T1 will give you what? V1 times T2. If you divide by T1, divide by T1. So you are going to say V2 will give us what? V1 T2 over T1. What's our V1 here? That will give you 283 times our T2 is what? 303 Kelvin. All over our T1 is what? 283 Kelvin. And this is going to give you 303 centimeter cube. Have you seen how we did it? And so very simple. Now let's take another example and see how we can still apply this law in solving. So here we are to the volume of an ideal gas at constant pressure increases from 50 centimeter cube to 80 centimeter cube. If the initial temperature of the gas is 70 degrees Celsius, calculate the final temperature. Here we are to calculate the final temperature. So we know very well what are the values given here. We're given the initial volume V1 to give us what? 50 centimeter cube. And what's our T1? Our temperature, initial temperature was what? 70 degrees Celsius. So plus, let's say 273, which give us what? 343 what? 343 Kelvin. Now, what was our second volume? Our second volume or the final volume was 80 centimeter cube. And then what was the temperature? The second temperature, the final temperature, we don't know. So from the relation, we know V1 equals to what? V1 over T1 equal to V2 over T2, right? So you are finding T2, so let's cross multiply. So you know V1 T2 will give you what? V2 T1. So we divide by what? We divide both sides by V1. Okay, so we are going to have that of V2 T2. We are finding the second temperature T2. If this cancels this one, we are going to have T2 to do V2 over T1. V2 T1 over V1. So what was our V2? V2 was 80. What was our T1? 343, right? 343. What was the initial volume? 50. And so if you input this, you are going to get 549 Kelvin. But because the other volume, the temperature was in degrees Celsius, we can change this one to degrees Celsius. If we want to change it to degrees Celsius, just subtract by 273. So you are going to get 549 Kelvin minus 273, which will give you 270, right? 276 degrees Celsius. Because you have 549 here, right? So if you subtract this one from it, you are going to get 276 degrees Celsius. 276 degrees Celsius. So you see that 549 Kelvin or 276 degrees Celsius. But because the initial one was in degrees Celsius, we can still put our answer in degrees Celsius. So that's all about the Charles law. Now we have another law where we will look at which of them that will. Alright, so we have the pressure law. For the pressure law, remember pressure pot, pressure pot, pressure pot, pressure pot, pressure pot. Now look at this one. Pot here means the pressure is directly proportional to the thermodynamic temperature. Pressure pot. Is that okay? Pressure pot. Now what means that here, what is constant? If you look at the three elements, what is constant? The volume is constant. So here we are going to talk about the pressure of what? A given mass of gas is directly proportional to the thermodynamic temperature at constant volume. Or somebody can say the pressure of a fixed mass of gas at constant volume is directly proportional to its thermodynamic temperature. Have you said it? So that is what the pressure law. Remember pressure law, pressure pot, and that will do for the pressure law. So as you can see, it said the pressure of a given mass of gas is directly proportional to its thermodynamic temperature at constant volume. So here, since we know pressure is directly proportional to the thermodynamic temperature, I told you for us to relate to gases, we have to make a constant. So P equal to a constant T. If you make K the subject, K will be equal to what? P over T. So therefore, you can say P1 over T1 is equal to P2 over T2. Is that okay? So this is a relation for two different gases, and this is a pressure law. Remember pressure pot, and that will help you to understand this concept very well. So let's take this question under the pressure law. The pressure of air in a tire is 22.5 Newton per meter square at 27 degrees Celsius. If the air in the tire heats up to 47 degrees Celsius, calculate the new pressure of air, assuming that no air leaks out and the volume is negligible. So with this particular question here, we are using the pressure law because we are only giving pressure and temperature, and it's only in pressure law that we with pressure and temperature. So we know the pressure here, initial pressure here is what? 22.5 Newton per meter square, and then the temperature here was 27, but remember it's thermodynamic temperature, and so we are going to add 273 to it, and we are going to get what? That of what? 300 Kelvin. The second pressure that we don't know, but know the temperature, which is what? 47. So 47 plus 273, and that's going to give us 320 Kelvin. Now from the pressure law, we know P1 over T1 will give you P2 over T2. Now you are finding P2, so let's cross multiply. So it implies that P2 times T1 will give you P1 times T2. So we'll divide up by T1. So we are going to have P2. So we are going to have P2 here to give you what? P1. What's our P1? P1 is given a question which is 22.5 times what our T2? 320 Kelvin all over. What was our T1? T1 was 300, right? 300. So if you put all these calculators, you're going to get 24 Newton per meter square, and that is it for the pressure law. The last thing is when we are finding the two equations, we are bringing all the three laws together. And so in the next video, we'll see how all these three laws are joined into one, what we call it the equation of state. And then we'll look at the ideal gas law and the real gas law. Then we'll look at the Van der Waals equation and the kinetic theory, and we'll wrap up with that of the thermal physics and the gases, and look at other concepts under the thermal physics. Please don't forget to subscribe and keep learning. Have a nice time.